All right, everybody. So let's do here. This is going to be 1.3, 1.3b, I guess you can call it. We're going to do limit, evaluating limits. Hold on. Evaluating limits. Evaluating limits. So we're going to talk today about another way to find the limits of equations. Right, so we know how to do it. We know how to find limits a few different ways, right? Ways to find limits. We have a few ways. Find limits. We can make a table. Right, you plug in some values very, very close to the number you want. That is a helpful thing to do. The more you practice that, the more efficient you can become plugging in numbers in functions, the better you're going to be all over the place. Make a table. We have a graph, obviously, graphs, looking at the picture, a very useful method. Finding a picture, looking at the bridge. We're looking at the bridge of the limit, and if it connects somewhere, right? Looking for that connection. If there's a break or something weird's happening, right? There's no limit. So graphs are very useful for identifying quickly if a limit exists or not. That's looking at the picture. Sometimes it's hard to tell in an equation. What we're going to talk about today is we're going to find out how to solve limits algebraically. This is evaluating or plugging in. How do we solve limits algebraically? And this uses some of the properties we talked about, right? We talked about how all you really need to do for limits is do the limit of the function itself. Anything around it, like there's a constant or a coefficient in front of a limit, or things like that, they just pop out, right? We just focus on the variables. Limits just focus on what's happening with the variables and how that interacts with the equation. So, easiest way to solve a limit is simply to plug in. Most of the time, this will work fine. Most of the time, you can plug in because most equations don't have anything weird going on, right? For example, if I say find the limit as x approaches 3 of 2x squared minus 5. To algebraically solve this limit, all you will do is take the 3 and plug it in. Whoa, goodness gracious. Why do you do this to me? Take this 3 and plug it in to the x there, right? So you would say this is going to be equal to 2 times 3. Let me do it over there. I need some room here. Equals 2 times 3 squared minus 5, which is 2 times 9 minus 5. Please, everybody, you're in pre-calculus. Do not make the mistake of multiplying first. PEMDAS, everybody. PEMDAS. Squares first. Exponents first. Come on, people. We can do this. Exponents first. 3 squared is 9. 2 times 9, that would be 18 minus 5 equals 18 minus 5. It's going to equal 13. There's our answer. No problem. Get a limit. Most of the time, you try plugging in, and that works great. Let's try this again. What if I gave you a little bit more complicated equation? The limit as x approaches, let's say, -2 of x squared minus 4 over x plus 2. Something like this. Like this. What do we do here? Well, again, let's try our easiest answer first, plugging in, right? Oh, Parisa seems to have found something interesting. Oh, God, why do you do that to me? No. Try again. Okay. Maybe this one. So let's take this -2, let's plug it in. Plug it in. We're going to get -2 squared minus 4 over -2 plus 2. And that's going to equal 4 minus 4 over 0, which is 0 over 0. And we have a problem. Yeah. Parisa noticed this problem. This is something that is very special in calculus. We call this, when this occurs, when you have an answer, you plug something in, you get something 0 over 0. This is called indeterminate form. Indeterminate form. This means we have to do more to solve it. 0 over 0 means we don't know what the answer is. Indeterminate form, when you get an answer of 0 over 0, it means we don't know the answer. Answer. It doesn't tell us anything except we need to do a little bit more work. Got it. Really need to get this pen working better. We don't know what this means. Is we don't know exactly what this answer is going to be. 0 over 0, if you get an answer like that, it means something is wrong, and we need to do a little bit more work to figure it out. And we'll see this again happen later on in situations where we get an answer of 0 over 0. That means we need to do something more. So we cannot solve this limit by plugging in. We get this indeterminate form, this 0 over 0 answer. So how do we determine it? What are some tricks? What are some tools we have that we can do, something we can do to this equation to help us to solve it, right? And so there's a lot of little, a lot of these little tricks and things, these algebraic methods, right, to solve. What can I say here? Stop it. Some tricks here. One of our tricks is to factor. So say we have this limit as x approaches -2 of x squared minus 4 over x plus 2. One of the ways we can simplify this function here, this equation here, right? We can simplify this equation here is by seeing if we can do some factoring. And let's look at the top here. I mean, the bottom we can't change, but look at the top. X squared minus 4. This is a perfect difference of squares. Difference of perfect squares. X squared and 4. Right? We can factor this. Hopefully we remember how to factor this into our two parentheses. Right? So we're going to say that this is going to become the limit as x approaches -2 of, right, x, this factors into two things. We have x plus 2 times x minus 2 over x plus 2. This difference of squares, x squared minus 4, remember this is a perfect square. We can break this apart into two factors x plus 2x minus 2. Everybody remember how to do this? This factoring, right? Simplifying. And once we did that, if you notice, something interesting on the top here and on the bottom we have this x plus 2. So I can cancel this and simplify. And so what I get, this is going to equal, I guess I can go over here, equal the limit as x approaches negative 2 of x minus 2. Okay? And now I can plug in and solve this. Right now, I'm allowed to plug in. So this is going to equal, I'm going to plug in my negative 2. I'm going to get negative 2 minus 2. I'm just not even going to have that parenthesis there. Hold on, everyone. Which is going to equal negative 4. And that is the answer to my limit. So what we did, we took this limit, right? We factored apart the top part in order to find a piece that we could cancel, and this piece we canceled was the thing that was holding us back, right? Both of these two pieces are what became a 0. And so when we do this simplifying, we're factoring out this piece that breaks it. This is causing our drama here. This is our hole. We factor that hole out, we cancel that part, and we see what the secret answer is of the problem when we plug in our negative 2. This negative 2 will become negative 4. This equation here simplifies to this one. Now we know that we can't actually, in the original equation, we still have to think we're actually finding this limit of this original equation. And we know that the actual answer of negative 2 doesn't exist. There is no real answer negative 2. But since we got this indeterminate form, we can do a little trick. We can do some simplifying and get a kind of what do I call it? We can get a our sneaky answer, our hidden answer. Right? The 0 over 0 tells us there's some hidden answer in here somewhere. And to find that hidden answer, we do the simplifying. We find the hidden equation and we get our hidden limit. This negative 4 tells us where this limit is. Now something I want to point out to you that's very important. Notice that when I did this problem, I kept writing limit, limit, limit. And then I stopped writing the limit as soon as I plugged in the negative 2. I didn't write it anymore right here. But I wrote it for these first few steps. I wrote it for these first few steps. You must continue to do this. The reason why I did it here is you must write the limit as you simplify. The reason I'm telling you this is because they will grade you down on the AP test if you don't. On the free response questions, if they give you a limit and you just ignored and you didn't write the limit here and you didn't write the limit here as you simplified, this, if without the limit here, this is not equal to each other. The limit is not equal to this equation. It's a different thing that you're making. So you have to write the limit as you simplify, as you're creating your equation. The one time that you can stop writing the limit, right? You can stop writing once you plug in. Once you plug in, no more. I don't know how do I say this? You don't need to write limits anymore. You don't need limit anymore. Once you plug in, only then can you stop writing the word limit. As you're simplifying, as you're doing this cancellation stuff, every time, keep writing the limit. Once you plug the variable in, once you get rid of our variables, once you have just numbers left, this part right here, you don't need to write limits anymore. Once you've plugged in, you're now doing the limit. Now you're evaluating the limit. But as you simplify, you need it for each of these steps, right? As we go through this calculus course, what we're doing right now, AP Calculus and Calculus in general, there are a lot of these kinds of formalities, these kinds of expectations, because mathematics is a precise field. And if you want to operate in this precise field, you must adhere to the precise definitions and the precise meaning of these things. If you use an equal sign, you better darn well be sure that the two things you're showing that are equal are actually equivalent to each other. Okay? And that is what they want to adhere to in this AP Calculus class. These precise definitions. They don't want any sloppiness. They don't want you to be sloppy anymore. We are expecting, accuracy from everybody. So we'll be talking about these details, these precisions as we go along. And the first one we want to highlight is this limit one. Make sure you write these limits as you're simplifying. Okay? What else? All right, let me give you another example. Another trick we do. Oh God. Another trick. Sometimes, so we can factor things, right? We can do this factoring. That's not a problem. We also have. Sometimes we will need to rationalize. Whoa, goodness gracious! Come on, pen, work with me here. Rationalize square roots. So sometimes we have limits where we have like a square root. For example, let's say we have the limit as x approaches 0 of, let's see, what's a good one? Let's do the square root of x plus 1 minus 1 over x. Yeah, that's a good one. Square root of x plus 1 minus 1 over x. Always, the first thing we want to do, check to see if we can plug in. Check by plugging in. If we can solve it by plugging in, then we're done, right? So if I plug in, I get the square root of 0 plus 1 minus 1 over 0. That's going to be square root of 1 minus 1 over 0, which is going to be 0 over 0. So we have our indeterminate form. And that tells us that we need to do a little bit more simplifying, do a little bit of trickery. We tried it by plugging in. That didn't work. All right, fine. Let's deal with it. Fine, let's deal with it. How do we deal with this? Well, we did a little bit of this some time ago, a year or two ago, in a previous class, when we had square roots and we had to cancel a square root that was on the bottom. We do something called rationalizing. What rationalize means is you're going to multiply by the conjugate. Conjugate. Remember, conjugate just means take the same thing, the square root part, this upper, I'm going to do this in green, this upper square root part, and I'm going to multiply both of these things by the conjugate. So I'm going to do square root of x plus 1 plus 1. Right? My conjugate means I'm changing this minus sign into a plus sign. Conjugate means the opposite symbol. And the same thing on the bottom, square root x plus 1 on the bottom. So I multiply the top and the bottom by the same thing. Okay? This is how we rationalize our square root. So then this becomes equals limit as x approaches 0. And now I want to do a little bit of multiplying here. I'm going to multiply these conjugates together. I do my foiling. Do this over here. Separate that out. Multiply these together. If I multiply the square root of x plus 1 times the square root of x plus 1, that just becomes x plus 1. No more square root, right? Square root times the square root cancels out. They become regular x plus 1. And then if I multiply the square root of x plus 1 times 1, I'm going to get plus a square root of x plus 1. That's going to be the top, right? That's that multiplication. Right? Square root of x plus 1 times 1 becomes just anything times 1 stays the same. Square root of x plus 1. So that's this first part. Maybe I should do this in like colors. I don't know. Let's leave it like this. So that's the first one multiplied by both. Now the negative 1 times square root, that's going to be minus square root x plus 1. Oh, that's very useful. And then negative 1 times 1 is going to be minus 1. And that's the top part. Okay? That's the top part. Bottom part, I am not going to multiply. I leave it as x square root x plus 1 plus 1. So multiply the top. I should do that up here. Multiply the top. Leave the bottom. Multiply the top. Leave the bottom. Please make sure you yell at me if something doesn't make sense. Everyone see how we got this x plus 1? This thing came from doing x plus 1 times square root of x plus 1. I multiplied those two things together. And when you multiply two square roots, the same thing, it just becomes itself. This second piece came when I multiplied this x plus 1 times the 1 right here. Top piece, right? Square root of x plus 1 times 1 is just square root of x plus 1. This third piece with the negative came when I multiplied negative 1. This negative 1 times the root x plus 1 right there, right? I FOIL out, distribute out these two pieces. Negative 1 times root is negative 1 times root x plus 1. And the last piece, that negative 1 came by doing negative 1 times 1. So I multiplied out the top part into these four pieces. Okay. In the bottom part, I just left these two multiplying each other, left it alone. All right, so now we got this complicated thing. We're going to simplify. And we can do this really easily. Look at this square root part. I have a positive and a negative, the same thing. They go away. So I'm going to have the limit, I'm still simplifying, the limit as x approaches 0, of x plus 1, and then minus 1, over x times root x plus 1 plus 1. And again, some simplifying, look at this. Plus 1 minus 1, those things go away. And so I have the limit as x approaches 0 of 1. Oh, not 1, sorry. Of x over x times this whole square root thing, x plus 1 plus 1. And I can do one more set of simplifying, something that's very, very helpful. What can I get rid of now, everybody? What can I cancel? Yes, indeed, this x on the top, this x on the bottom, can cancel each other out. And that is the key. That lets us get rid of our problem, right? This is our problem, this little problematic x, making this function not work. And that's how we can work this out. So that's going to be equal to, equal to, again, still simplifying, the limit I haven't plugged in yet, still got to write the limit. Limit is x approaches 0 of 1 over square root x plus 1 plus 1. And now I can plug in. I don't need to write my limit anymore. I'm going to do 1 over square root of 1 plus 1 plus 1. It is 1 over root 2 plus 1. And that's our answer. Oh my gosh. Mr. Mitchell. Oh my gosh, I plugged in 0. You're right. I was too many ones. Thank you for reminding me. I was too excited about ones. This is not a 1. This is 0 plus 1, which is okay. Well, that's very much better. That's just going to be square root of 0 plus 1 is square root of 1. That's going to be 1 plus 1, which is going to be 1/2. Much better. Thank you for catching. I was too excited about my ones. Thank you for catching that. The answer is 1/2. -10 points for Gryffindor. -1,000 points for me. Yes, exactly, Barry. So, all right. Questions? Rationalizing means, and for these kind of questions, whenever there's a square root, always your first step, check by plugging in. If it's something you can plug in and solve, you're done. But if you plug in and you get a 0 over 0, or you can see that it's going to become 0 over 0, and it's got a square root in it, square root, we solve the rationalization step. That's this possibility of rationalization, where you multiply by the conjugate, multiply by the opposite signs, right? If this is a minus, this is a plus. Nothing else changes, just the sign in the middle. The middle one in the square root, right, this x plus 1, that didn't change. The only one that changes is between the two pieces, the plus in the middle. So rationalizing is an option. Factoring, that's also an option, right? You cancel, you're simplifying, right? You're canceling by factoring, rationalizing. What else? What else? We'll do one more example. How much time do we have? Oh, we're good. We're good. We got 20 minutes. All right. Let's do another example. What if I gave you something like the limit? Let's do as x approaches 0 of 1 over x plus 4 minus 1 over 4 over x. Limit is x approaches 0 of 1 over x minus x plus 4 minus 1 over 4 over x. Should we try plugging in? What do we think is going to happen? Let's just look at it without actually plugging in. Let's just kind of imagine what's going to happen here. So we have our 0, right? X is becoming 0. I plug a 0 here. I'm going to get 1 over 4. I plug a 0 here. I'm going to get 0. 1 over 4 minus 1 over 4. That's going to be 0. So I can already tell I'm going to get a 0 over 0. I can already tell. Right? I don't even need to like try it out. I can just look at it and like in my mind see, right? That's going to be a 0, 1 over 4, 1 over 4 minus 1 over 4, that's 0, 0, 0. Okay, that's going to be a problem. I need to solve this some other way. Can I factor this? Is there anything that's factorable? I don't see any squares, x squared anywhere. I don't see a trinomial. Remember all our factoring methods see a difference of squares. I don't see group factoring. Oh, I have enough group. No kind of factoring is going to happen here. No kind of factoring I can do. Okay, well, our other tool was the conjugates, right? The multiplying by the rationalization. And now it's not a square root, but we still have this ability to do conjugates. So let's try. Let me try multiplying by the conjugate of this top thing. No, Lisette. We have all this ability. We have so many talented people here. We can do all these conjugate things. Conjugate of this, 1 over x plus 4, 4, plus 1 over 4. Same thing on the bottom. Same thing on the bottom. 1 over x plus 4 plus 1 over 4 on the bottom here. Appreciate all the, what is it? Show respect. Press F to show respect. Good game. Good going. Conjugates, people. Press F to show your conjugate skills. Exactly. Thank you, Reyes. You got those conjugate skills. So we're multiplying by the conjugates. Let's do this. Not a big deal. We'll be fine. Everything's okay. It's just a whole bunch of fractions. Everybody loves fractions, right? We're all okay with this. Equals limit. Hope you have enough paper, everybody. As x approaches 0, up. Let's do this conjugate part up here. Multiplying. Okay, now we got to multiply this 1 over x plus 4 times 1 over x plus 4. I mean, I'm just going to write this out for right now. 1 over x plus 4. Oh, God. 1 over x plus 4 times 1 over x plus 4. And then I'm going to do plus 1 over x plus 4 times 1 over 4. That's the second piece here. Minus, these two multiply together, 1 over 4 times 1 over x plus 4. Multiply these two together, minus, that's going to be 1 over 16. Right? 4 times 4, 16. 1 over 4 times 1 over 4. Maybe later. We'll see if I can finish this in 10 minutes, Lizette. If I do it now, it'll be on record. It'll be recorded. Oh dear. That's a dangerous prospect. All right, so that's our top part. Whole thing divided by, I'm not going to, remember, bottom part we don't multiply. X times 1 over x plus 4 plus 1 over 4. Leave the bottom part alone. Equals. Let's see if we can simplify this. Multiplying these top pieces here. Multiplying these top pieces here. So I've got 1 times 1. Well, that's a. Oh, I need to write limit. Limit. We're still simplifying. Limit as x approaches 0. So I've got 1 over these two things on the bottom part. I need to multiply these two things together. So I'm going to multiply. I'm going to get x squared minus plus would be plus 8x plus 16. Minus 1 over 16. Is that what I want to do? Multiply those things. I know that these middle pieces, look at these. Plus this, minus this, these two are going to cancel out. This is true all the time. When you do this conjugate stuff, those middle pieces cancel out. So that's what I've got for the top. On the bottom, goodness, it's really messy, isn't it? Over x4. Let's see. Over x times 1 over x plus 4 plus 1 over 4. Any ideas, folks? This was x times x plus 4 over x plus 4. That was that thing there. I have this fraction on the top. I got these fractions on the bottom. We deal with it. No, we deal with it, right? We deal with the situation that we're given. Right. So, well, I guess what we can do, we can try combining these top fractions. That means I have to have a common denominator. How can we do that? I'm trying to think if there's a trick I'm forgetting about. Oh, you know what we should have done? You know what we should have done, everybody? I made this really much harder than it had to be. Yeah. I think there's an easier way to do this. From the very beginning. So this conjugate thing, I think, is a mistake, because this is going to be very complicated. Let's try another method. Let's try another way. The trick here, dealing with fractions. So let's start again. Limit as x approaches 0 of 1 over x plus 4 minus 1 over 4 over x. When dealing with fractions, we don't want to do that conjugate rule. We don't want to do that. We can't factor anything, right? When dealing with fractions, what you want to have is you want to combine fractions together as soon as you can. Combine fractions as soon as possible. And you have to use common denominators. Common denominators. So for the top part here, what we can do is we can give this piece here, multiply 4, and give it this 4, and multiply this part, top and bottom, by x plus 4. Let's do this. I think this is going to be a much simpler way to do this. Does everyone see what I did up here? I gave, like, crisscrossed, right? I gave the 4 to this side, and I gave the x plus 4 to this side. I found a common denominator by giving each piece what the other one was missing. This first fraction was missing the 4 on the bottom that this one had, so I gave it to this on the top and bottom. And this one was missing this x plus 4, so I gave it to this on the top and the bottom. So let's see what that does. Limit as x approaches 0 of 4 over 4x plus 4 minus x plus 4 over 4x plus 4 over x. This is much, much better. And now what we can do, now that these top ones, these top pieces have the common denominators, right? 4x plus 4, 4x plus 4. I didn't multiply them. I mean, I could have. It doesn't matter. Let's just keep it simple. I'm going to combine these two top fractions into one. So I'm going to say it's going to be 4 minus x plus 4 over 4x plus 4 over x. See, look what I did here with this parenthesis. I put a parenthesis around this x plus 4 because the entire thing is negative, right? I need to take this negative, and I should distribute that negative to both of these two pieces. Limit x approaches 0 of 4 minus x minus 4 over 4x plus 4 over x. And distribute that negative to both of those. And now I see I have a 4 minus 4. These two things will cancel out. Oh God. My big fraction is right there. So I've got negative x, limit, as x approaches 0, of negative x over 4x plus 4 over x. I got a fraction and a fraction. This x is over 1 on the bottom, and now I have a much better approach. Instead of now dealing with pluses and minuses, I have this fraction. This bottom fraction, I can take this x over 1, and I flip and multiply. Flip and multiply. And I cancel out that fraction stuff, so again, let's take a look here. Limit, as x approaches 0, of negative x over 4x plus 4 times 1 over x, and now my x's are going to cancel out. There's how we solve our dilemma. Limit, as x approaches 0, of negative 1 over 4x plus 4. Now that I've solved it, I can plug in. That's going to equal negative 1 over 4 times 0 plus 4, which is negative 1 over 4 times 4, which is negative 1 over 16. Answer, everybody. Whew. Yes, under fraction says with common denominator, yes. So 3 tricks we talked about. Factoring. We talked about conjugates. Really only use conjugates with square roots. It doesn't work out with fractions. And dealing with fractions, you want to make common denominators. So 3 tools that we have that we can solve these limits with. Okay. Yeah, let me move this. Oh, down, like this way. Like that. How's that? Is that okay? Question, Jessica, yes. Cross multiplied. You're talking about up here? Cross multiplied? Or do you mean down here on this, like here on the side? Down here. So what we did here, right, when we had our 2 fractions, once we made a fraction over x, this x part on the bottom is also a fraction, right? So we're going to make, instead of having like a fraction divided by a fraction, we take the bottom fraction, flip it, and multiply, right? So it's instead of x over 1, we make it the top part, which was negative x for x plus 1, x plus 4, times 1 over x, and then yes, I multiplied the top parts, but I see that this x here and this x here they cancel each other out. And so when I multiplied here, the top part just became, this is negative x, so that was negative 1, negative x here. And then this part became still on the bottom, the same thing on the bottom. Yeah? Was that your question? This part here? And then I just plugged in my 0, and I got that. Very good. All right, 2 more minutes. Let me show you one more thing. Oh, goodness, I'm running out of space. Well, this happens sometimes. One more thing, and it's going to be quick. And this is just something I want to show you a couple of questions you're going to have in the homework of using properties. So we talked a little bit about this. I just want to remind you about this. So everything I showed you today is what your homework is going to be based on. Plugging in, testing your limits by plugging in. If you can't plug in or you get an indeterminate form, you have those 3 tricks. You have factoring, you have conjugates, and you have fractions. This last part, I want to show you, using these properties, remind you about how to do this. So if I tell you, for example, if I say the limit as x approaches, I don't know, let me call it c, of some function f equals 3, and the limit as x approaches c of g of x equals like negative 2. I can do a lot of things with this, right? I can give you, for example, find the limit as x approaches c of some complicated thing like 2f of x minus 4g of x. I can do something like this. Okay? And no matter how complicated this thing becomes, no matter how complicated this thing becomes, all you're really going to do is notice that you're going to apply this limit to the f and to the g. And we know what those become when we do that. So it's kind of like you're just plugging in anyway, right? This is going to equal 2 times f of x, when I plug in the limit of x approaches c is 3, minus 4, g of x, when I plug in the limit is going to be negative 2. And I don't write the limit because I'm plugging in now, so that's 6 plus 8, that's 14. So that's going to be the last kind of question that you see using these properties. And just know that when you have these complicated equations, all you're doing is plugging in the limit. You're doing the limit for the functions, and you're going to get the answers that they tell you, whatever those things are. Plug in the limits. All right. Your homework, like I said, is going to be posted to Schoology. It's going to be page 71. 71. Some problems that I have to remember, but it's posted to Schoology. See the one before this. Here's this one still. Again, I recorded all this, so I'm going to post that up to Schoology. Well done, everybody. If you're all good, you can say goodbye in the chat. and you're free to go. If you want to stick around, I can scroll up and down. Otherwise, have a great 4-day weekend, everybody. I'll see you next time. Have a good one.